Hello everyone, my name is Rutvik Reddy Kamam and today I will be presenting my final project on customer churn prediction in a telecom company. This project showcases the complete data science lifecycle applied to a real world business problem. The aim is to use machine learning to not only predict which customers are likely to leave, but also to understand why and how we can prevent it. This topic is critical in telecom because customer retention is often more cost effective than customer acquisition. Coming to the next slide. The core objective of this project is to predict customer churn using machine learning and to gain insights from customer behavior and service usage patterns. In this project, and I have analyzed key aspects like contract type, tenure, and use of online services to identify which customers are most at risk. And with these findings, I have proposed actionable strategies to improve customer retention. And the project focuses on both the technical modeling and the business interpretation of the results. So the outcomes are both accurate and useful. Coming to the slide 3. The dataset used in this project is the Telecom customer churn dataset from Kaggle. It contains 7043 customer records with 21 features. The target variable is churn, which indicates whether a customer left the company. The key input features include tenure, internet service type, online security, tech support, and contract type. These variables offer detailed information about the customer engagement and billing, making them highly relevant for churn modeling. The dataset is rich and covers a variety of behavioral and demographic factors. Coming to the slide 4. In the EDA phase, I found that the overall churn rate is about 26.5%, the meaning more than 1 in 4 customers leave the company. And this is a significant number and calls for closer analysis. And I also identified 11 missing values in the total charges column, which I later addressed during pre-processing. From visualizations and distributions, it became clear that customers with month-to-month contracts, high monthly charges, and short tenure, especially under 6 months, are at the highest risk of churning. These patterns guided later feature engineering and model tuning. Coming to the slide 5. This slide continues to show the deeper insights from exploratory analysis. The visualizations like box plots and count plots confirmed our assumptions that customers who use fewer services and have short contract commitments are more likely to churn. And these EDA results helped define our hypothesis and inform the choice of features for the model building. Coming to the next slide. For data pre-processing, I first handled missing values in the total charges column using median imputation. Categorical variables were label encoded to convert them into numerical form. And then I applied standard scalar to normalize numerical features like tenure, monthly charges, and total charges. Outliers were treated using the interquartile range method, which capped extreme values without removing too much data. All these steps were essential to prepare the data set for effective model training and to ensure the consistent performance. Coming to the next slide. The feature engineering helped enhance the predictive power of the model. I created a new feature called total services by summing up the binary service columns, giving a single indicator of how many services a customer uses. Another important feature was average charges, calculated as total charges divided by tenure plus 1. To account for new customers, PCA was applied to reduce dimensionality while retaining 95% of the variance, helping in simplifying the dataset. Finally, I used recursive feature elimination with a gradient boosting model to select the top 10 most predictive features. Coming through the next slide. In this slide, I discuss how feature importance was evaluated, and the features like contract type, monthly charges, and tech support showed the highest predictive power, and the visualizations confirmed that these features had strong separation between churn and the non-churn customers. This process ensured that the model was both accurate and interpretable, which is crucial when delivering insights to the stakeholders. And coming to the next slide. For the classification task, I used a decision tree model because of its simplicity and interpretability. I also split the data into training and test sets with an 80 by 20 ratio. The model achieved an accuracy of 80% with precision of 0.73 and F1 score of 0.70. These are the solid performance metrics for churn prediction. I also applied K-means clustering to identify the customer segments. This helps in understanding the customer profiles and can be used for targeted marketing. The Silhouette score of 0.36 indicates moderate separation between the clusters. Coming to the next slide. To fine-tune the model, I used Grid Search CV to optimize the parameters like max depth and minimum samples split. I validated the model using five-fold cross-validation and achieving a consistent mean accuracy of 0.79. The evaluation was also supported by ROC curves and AUC scores, along with confusion matrix plots to visualize the model's classification capability. These metrics prove that the model is not only accurate but also reliable across different data splits. Coming through the next slide. From the modeling results, I derived several business insights and the customers who are new have high charges and are not subscribed to value added services like tech support are more likely to churn. Therefore, the companies should implement strategies like onboarding offers for new users, encouraging upgrades from month to month to annual contracts, and bundling useful services like the tech support and online security. These are the actions can significantly reduce churn. In addition to the churn prediction scores should be integrated into CRM systems to alert the retention team about high risk customers. Coming to the next slide. In conclusion, this project successfully demonstrates the application of the full data science workflow to a real world business problem. And I started with data cleaning and exploration. I created meaningful features, built and evaluated predictive models, and finally, the generated actionable business insights. The results can directly help telecom companies retain more customers and reduce operational losses. And I believe this project shows how data science can provide both can can uh, both technical accuracy and the business values. Thank you.